What up, Sci Fam? It's your boy Nickel, and I'm going to teach y'all how you can be excellent scientists by starting the scientific method. We're going to title this page, as I just said, Starting the Scientific Method, because we're just going to look at those first few slivers of our donut that we did in our last science notebook video. So we're going to look at what it means when we make an observation, what it means when we ask a question, what truly is a hypothesis. We'll define an independent and dependent variable, and I'll also discuss what it takes to actually build a hypothesis. So you can kind of see how your page is going to be set up with each of these different portions going just here on the one page. If you need to go on to the next page, that's possible too, but hopefully with this layout you can kind of get an idea of what to expect. So again, title your page, Starting the Scientific Method. And we're going to start by looking at observations. So observations are basically meaning that you're noticing things. You're just noticing. Or maybe observations mean that you're actually asking questions. Because if you notice something, usually you're going to ask a question. And that does relate to another step in the scientific method, but sometimes we're not ready to ask our overall question yet, and we're just asking some random questions as we make some observations. This is kind of like brainstorming. We're also typically sharing data and ideas with the world around us. So when you watch the news, when you get on social media, data and ideas are constantly being shared, which are other forms of observations. Another idea or another way that people make observations is from following their inspiration. So maybe someone's on the guitar, they're riffing on the guitar and they start to notice something, but they're just following their heart, they're just following what inspires them, and all of a sudden they start to notice a pattern. And then sometimes people make observations from exploring different research. So maybe they're curious about something, like they're researching a new dog, and they start to make observations about dogs because of this research that they're exploring related to this topic. So observations are typically coming from these areas, and once we have made plenty of observations, then we can develop an appropriate question that can then be tested, or the question that we really want to focus our experiment on. So our question is going to be based on practical problems, like something that we need to overcome, like how do we breed a German Shepherd with a lab or something like that. That could be a practical problem. Is how do we actually go about doing that? Or the question could be, well, how do you design a car so it has the maximum safety rating? That could be a practical problem that we want to try to solve, and so that would help. That practical problem helps address what our question is. It could be based on our observations. Our question could be based on those observations we made, and most of the time they are. It could also, our question might stem from our personal motivation. So maybe you started a business and you're really motivated to get your business off the ground, and so you ask a question like, how can I reduce the amount of cost it's going to take for me to purchase the materials? That could be a question. So it could be a personal motivation, or even just a curiosity, something that you're curious about. Or it could be related to some new type of technology. So maybe you got a new piece of technology, you're like, whoa, how does it do this? And then you go on to investigate that question. Now, once you have a question, you're wondering about something, then scientists will develop a hypothesis. And a hypothesis is an explanation that can be tested. It has to be able to be tested. You have to be able to run a test in order for it to be able to be an accurate or a valid hypothesis. If you can't test what your explanation is, like if you say that ducks are happier when they eat ice cream, well, if you can't test that, then it wouldn't be a hypothesis, but that is something that you could test. Well, you could try, but how do we actually measure happiness in ducks? So maybe that's not an actual valid hypothesis. Instead, maybe we need to ask the question of what type of food do ducks prefer? So you can see how it needs to be tested. When we really dig down at our explanation, it must be able to be tested, and we test that through study or investigation. Now the goal here is to explain how one variable will affect another variable. Like for example, the happiness of the duck. How is that going to be affected by the type of food we give it? So there's two types of variables that are going to be in a science experiment. And what we really look at in the hypothesis is how does the independent variable, will affect the dependent variable. So one is the independent and one is the dependent. So the dependent one is supposed to depend on what happens to the independent one. The independent one will impact the dependent one. The dependent one is dependent on the independent one. That is the goal here in our hypothesis. So let's dig a little bit deeper into this. What is an independent variable? Well, we can summarize it here by just calling it an IV, independent variable. And this is the one and only one. So underline that a bunch of times. It's the one thing that you will change throughout the experiment. And we're going to do that to see how it impacts the results or the data or the dependent variable, because the results and the data is the dependent variable. So let's define that next, and then I'll give you an example. So dependent variable. We'll summarize that or abbreviate that with D.V. Now these abbreviations will help us as we write down notes, but when you record your assignments in class, you need to spell out dependent variable and independent variable. So make sure that you have those spelled correctly. The dependent variable is the results or that data. It's the data that is collected by the scientist. So let's go back to my idea about a duck and being happy with the food it eats. Well, the thing I'm measuring is how happy it is. So the dependent variable, the data I'm collecting, is how happy the duck is. It's the data I'm collecting is the happiness of the duck. The one thing that I'm changing to see how it affects the duck's happiness, the one thing I change is the food I give it. So in my experiment, I must only change the food that I'm giving the duck to see how it impacts the dependent variable or its happiness. And its happiness depends on the type of food that I give it, which is the independent variable. So in this example, if I were to come up with a hypothesis, whenever we write a hypothesis, we say if, and then you're going to talk about the independent variable here, and you're going to talk about how it's going to impact the dependent variable here, and then you give me a reason why in the because portion. So if we're going to do the duck and the food, I could say if, and if the independent variable is the type of food, and the dependent variable is the happiness of the duck, I could say something like, if I feed a duck ice cream, then it will, and it needs to be about the happiness, it will be less happy than if it eats duck food, whatever that is. Because, and I'm going to say the reason why I think that a duck would be less happy if it eats ice cream compared to duck food is because ice cream doesn't have enough duck nutrition, or nutrition for ducks, the vitamins and minerals that they need. So here we go. Here's the independent variable. Let me highlight the independent variable in pink. If I feed a duck ice cream, there's my independent variable. That's the one thing I'm going to change, is what am I going to give it, is the food I feed it. Then the dependent variable is that I'm going to look at it will be happy. So it's the happiness. Okay, now I accidentally highlighted the because part, so let me go back here. So the independent variable is in pink, the dependent variable is in green. So I used green here, and I used pink over here. So if I feed a duck ice cream, that's the only thing I'm going to change, then it will be less happy than if it eats duck food, because, and then my because part I'll do in, let's do yellow. The because part is because ice cream doesn't have enough duck nutrition. So you can see every hypothesis has 3 parts to it, and this is something I can now test. I can feed a bunch of ducks ice cream, I can check their happiness compared to when they eat regular duck food. Now, if I were to do this experiment, and if I were to also change something else, it would completely ruin my experiment. But we'll talk more about that in our next science method videos. So the main goal here is that you understand these basic components, and that you will need to know the difference between a dependent variable and an independent variable. That will be very important. So I'm going to give you one last tip here on how you can help remember the difference between these two variables. I want you to add a little part here to your notes. So the independent variable, the way I can remember this is that it starts with the letter I. And the letter I stands for we'll call I will change. It's the thing I will change. I will change this thing. So in this time, what's the thing I'm going to change? The food. So the food is the independent variable. The dependent variable starts with the letter D, and D just stands for data. What is the data that I'm collecting in this experiment? Well, it's the happiness of the duck. So the duck's happiness is the dependent variable. The thing I'm going to change is the independent variable, and that was, again, remember, the food. So you'll use this as you complete the next assignments in this unit, and please touch base if you need some help. I'll catch y'all on the next video. Peace.